This is A2Further Maths. We're looking at Unit 8, hyperbolic functions, and this is 8.4, taking a look then at inverse hyperbolic functions. So if you remember your inverse functions from A2 Maths, you know that only one-to-one functions can have an inverse function. Since sine is a one-to-one function, so look at sine, this is it here. Don't get mixed up, don't be thinking it's this here is sine. So at no stage is that kind of back onto itself, so that's one-to-one. Its inverse function is r sine, and the graphs then look like this. So as you hopefully know then about functions, if you reflect in the line y equals x, you get that. So there's sine, and r sine then looks like that. Note as well, so this isn't arc sine or arc sine, it's called r sine, which is then the inverse function. Similarly, tanh is a one-to-one function. Its inverse function r tanh, and the graphs of these functions then look like this. So if you remember a couple of videos back, the video of tanh looks like this. Reflecting then y equals x, r tanh is going to look like this. Now with new asymptotes then at x is minus 1 and x is 1. Over the page then, for the function cos x, you need to take the domain of x is greater than or equal to 0, because cos obviously looks like this, so that's not a one-to-one function, so we need to cut it short. So we're taking this domain now as x is greater than 0, so that it's a one-to-one function. Then the inverse function r cos is defined for the domain x greater than or equal to 1, and the range r cos is greater than or equal to 0. The graphs of cos and r cos then look like this. So there's cos, if you remember from the previous videos, and then r cos is going to look like that. Similarly then, so example 1, it says to, on the same graph, sketch sech for x greater than or equal to 0, and then r sech. So we did sech a little bit earlier on again in the previous video, so hopefully you can see it. Remember, it goes through the point 0, 1 and sech, and again we've cut it in half here because it would make it one-to-one, and then if you reflect that on the line y equals x, we get our r sech, which looks then as this graph here. And that's our graphs then of some of our hyperbolic functions. Okay, just to talk through then, so this is 8.5, logarithmic form of inverse hyperbolic functions. Since hyperbolic functions are defined in terms of the exponential functions e to the x and e to the minus x, it's possible to express their inverse function in terms of natural logs, because obviously ln x is the inverse then of e to the x, like this. So if we want to write r sine x equals u, then we can write x equals sine u. So if we let x equals sine u, and we then have a half e to the u minus e to the minus u, that means x is a half e to the u minus e to the minus u. So try to rearrange this and try to get it then on a different form. So if we times everything by 2 and take it over to the one side, so times by 2 changes this to a 2x, gets rid of the half here, and we end up with that. Multiplying through then by e to the u, that changes this to a 1. Remember, e to the u times e to the minus u gives us e to the 0, which is just 1. Gives us e to the 2u and then 2x e to the u. This is a quadratic equation in e to the u. By adding x squared to both sides, a bit of a trick there, and you can write it then as e to the 2u minus 2x e to the u plus x squared, and then taking this 1 over the other side, we get then x squared plus 1. That left hand side then is going to factorize, and that should be a wee squared term in there. Hope you can see that okay. So it's e to the u minus x all squared equals x squared minus 1. Taking the square root of both sides, we get e to the u minus x equals plus or minus the square root of x squared plus 1. Getting the e to u on its own, we get equals x plus or minus the square root of x squared plus 1. Now that's the way you think about this. But e to the u is greater than 0 always, has to be. And therefore the negative sign can be rejected, because the square root of x squared plus 1 is going to be greater than x. So e to the u equals x plus, just the plus part then is required, square root of x squared plus 1. That means u is ln of this, x plus this. And so we had, if you remember, we defined down here our u as r sine x. So we can then write r sine x in terms of ln x, which is kind of what we had said. Ln x plus the square root of x squared plus 1. This one's given in your formula booklet. Similarly, you can show that r cos is ln x plus the square root of x squared minus 1, where x is greater than or equal to 1. And also, our tanh is a half ln 1 plus x, 1 minus x, where the modulus of x then is less than 1. Let's run through just a couple of examples then. Express r sine 3/4 in log form. So this is part A. Hopefully I can fit this in. So it's r sine 3/4. That's going to be ln, so we're just subbing straight into the formula. X is going to be 3/4 plus, remember this is x squared, so it's going to be this squared, so it's 9 over 16 plus 1. Now, let's see if we can tidy this up. So it's ln 3/4 plus, right, what are we going to have here? This is 16 over 16 and 9 over 16. The 9 to 16 is quite handy for us, isn't it? Because it gives 25 over 16. 25 over 16 is square root. Then it just gives us 5 over 4. 3 over 4 plus 5 over 4 gives us 8 over 4. And so it tidies up nicely then to ln2. Part B, r cosh of 3. So it's ln 3 plus 3 squared, take away 1. So it's 9, take away 1. Right bracket here, sorry. That gives me ln 3 plus root 8. Well, if you want to tidy up our third, then ln 3 plus 2 root 2. Part C, our tanh of minus 3/4. So we get straight into the formula. You can see it just up here. It's a half ln 1 plus or minus, then so it's plus minus 3/4 all over 1 plus 3/4. That gives us a half ln 1 take away 3/4 is a quarter on the top. 1 plus 3/4 then is 7 over 4. So effectively then I have a seventh. And if I take the half then up here, it's the square root of that. So it's going to be, what is it going to be? It's going to be ln 1 over 7 to the power of a half. Or if you want, so if we do that to the power of a half, or we take the minus sign out the front and go for an ln 7, which is going to work. So final answer I'm writing is a half ln 7. Hope you see then where that comes from. On then to example 2, wee bit of working out here and a bit of tidying up certainly towards the end. So find the values of x which satisfy sine squared x plus 5 equals 4 cosh x. This is very like our regular maths, only we're on hyperbolic functions here, so we're going to use our hyperbolic identity and rearrange then from there. So we know since cosh squared x minus sine squared x equals 1, that I can rewrite my sine squared x as cosh squared x minus 1. So it's going to be cosh squared x minus 1 plus 5 equals 4 cosh x. Rearranging here, we're going to have, let's just do it here, cosh squared x minus 4 cosh x plus 4 equals 0. That factorizes straight off. Some people might want to put a wee t in there or change it, we kind of then change it back again. But we effectively get cosh x minus 2 upon cosh x minus 2. So we get cosh x is equal to 2. So x is r cosh of 2. So How do we go about tidying that up? Sorry, too many pages going on here. That means x is going to be ln 2 plus 2 squared, so it's going to be 4 take away 1. So if you want, then x is ln 2 plus root 3. The other way we can solve it, so that's our final answer there. Sorry, there's a final answer there, so it'll work. The other option for us is to go cos x equals 2. We know what cos x is, don't we? We know it's e to the x plus e to the minus x all over 2, and that equals 2. That of course gives us e to the x plus e to the minus x equals 4. Multiplying through by e to the x gives us e to the 2x plus 1 equals 4 e to the x. So e to the 2x minus 4 e to the x plus 1 equals 0. Hope you can see then we have a quadratic then in e to the x. So what we want, we can have, well, I'm not even sure if it factorizes, but I can just use the formula. So e to the x is minus b, so it's 4 plus or minus the square root of b squared, so it's 16. Take away 4ac all over 2, and sure enough we end up with some similar. X is e to the x is 2 plus or minus root 3, or x then is ln 2 plus or minus root 3.